Hey guys, it's Mrs. Batchelder here. I hope it doesn't make you too sad, but I think this is going to be our last set of class notes and practice for the entire year in geometry. So here what we're doing is trying to find the area and the perimeter in the coordinate plane. So here we've got a nice quadrilateral, ABCD, and we're supposed to find its area and its perimeter. Now, if this were a plain rectangle, we could just add all the sides together because that's what it means to find perimeter. And if it was a rectangle, we could do base times height, but it's not a rectangle. We don't have nice 90-degree angles. It's not super stellar. And so what we're going to do is help ourselves out by boxing in the areas around it. So we're just going to say, what if we were to extend these sides out and then bring this way down here? Cross that one out. Here we go. So we're making a really big rectangle around the whole thing. And if we want to find this shaded region inside, our game plan is to find the area of the whole box. So the area of the big rectangle. And then we're going to subtract off all these other areas. So I'm going to color them in. So then we've got the orange region. And then we've got you know what I'm going to use? That would be better. The yellow region. And then we'll have the blue region over here. Let's make this. Get thicker. Let's make this thicker. And then, I don't know, this slime green region down here. We'll make it nice and thick too, so we can get this green region down here. And if we take my little eraser over here, and then what we're going to do is we'll add up the orange one, the blue one, the yellow one, and the slimy green one. And we're going to just subtract them all. So we add all those together and then just subtract it from the area of the big rectangle. Okay? And then it doesn't matter that the inside part is all that wonky shape. No one will really care. So let's go ahead and find the area of the big rectangle. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this part's 10. This part's 2. So this whole side up here is 12. And then this part here is 1, 2, 3, 4, 5, 6, 7, 8. This part here is 1, 2, 3. So this whole side length is going to be 11. So the area of the rectangle is going to be base times height. The area of our rectangle will be 12 times 11, which is 132 units squared. Okay, so there's the area of our rectangle. And then we're going to add up we're going to find each of the areas of the triangles and work our way through. So while I'm labeling, let me just keep going here. 1, 2, 3, 4, 5, 6, 7 here. 1, 2, 3, 4, 5 for the base of the yellow. This is 1 unit right here. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units on that portion of the yellow. Okay, so let's do, whoops, keep hitting the wrong thing. Let's do our orange triangle first. So we know the area of a triangle is base times height, and then we have to cut it in half. So if we think of the base as being this, I guess we could think that as the height. I guess the base would be 10. Doesn't really matter. 10 on one side and 1 on the other, because remember we have to have base and height be perpendicular. 10 times 1 and cut it in half. So the area of that triangle is going to be 5 units squared. And then if we look for our yellow one, area of that triangle, base times height divided by 2. Remember to show your work nicely because that's going to be your communication portion. I had measured this side and our height is 10 and our base is 5. So the area of this triangle is going to be 5 times 10 and cut it in half. The area of that triangle is going to be 25 units squared. Let's go ahead and do the blue one over here too. So the area of the triangle, base times height divided by 2. Base and height have to be perpendicular. They are because we boxed in a nice rectangle around. So if we do our base as 2 and our height as 8, 2 times 8, then we're going to cut it in half. And we get that triangle. 2 times 8 is 16. Half of that is 8 units squared. And then I'm going to do my green triangle down here. And our base was 7 and our height was 3. So area of the triangle is base times height divided by 2. 7 times 3, cut it in half. And our area is going to be 21 divided by 2 is 10.5 units squared. So our overall area of the shaded region, actually, let me not say shaded. Let me call it area of quadrilateral ABCD. Oopsie. Area of A, B, C, D is going to be 132. Subtract all the little triangles that we're going to snip off. So basically, we find the big one. We put all the way around it. And then we're just going to snip off the parts we don't want. So the orange part was 5. Then the yellow part was 25 square units. Blue part, 8 square units. Last snip was the green part, and that's 10.5 square units. So we end up with, we add those together, 5 and 25 and 8 and 10.5 is 48.5. So 132 minus 48.5 gives us 83.5 units squared to get our area of quadrilateral ABCD. So it's kind of cool. I really like this method because it's sort of like you can kind of picture having scissors and just snipping off the parts that you don't like. So that gets us our area. And then our next job is to find our perimeter. So to get the perimeter of ABCD, what color haven't I used yet? That one fades. That one does something different. I guess we can use this purple. Let's make it a little bit thicker. All right, to find the perimeter, I need to add all of these edges. So I need to find the length from A to D. And to get the length from A to D, remember A to D with no bar over it means its length. I can look at that orange triangle and it's a nice right triangle. And what works for every right triangle? Pythagorean theorem. So if we were to do leg squared plus leg squared is equal to the hypotenuse squared. You might have seen it as a squared plus b squared equals c squared. We're just going to fill in the parts. So the two legs are going to be the parts that touch the 90-degree angle. So that's going to be this length right here, which is 1. And then the other portion was this over here. So that's our 10. squared, because I helpfully labeled that before. It's almost like I knew this was coming. I know. Is going to be AD squared, because AD is the hypotenuse. So 1 plus 100 is AD squared. 101 is AD squared. And then we have to square root both sides. Now remember, when you square root, you get a positive and a negative, but we can't have a negative length. So we're going to take 101 and square root it, and we're going to get 10.05. We're going to go nearest hundredths place, and it's in units, because as opposed to units squared. So we know AD is 10.5 units. And now we have to find the rest of them. So let's go ahead and let me switch colors here. Can I pick a different color? Pick a red. So if I want to find from A down here to B, let's put a little dot right here. I'm going to find A, B, color code this out here. If I'm finding A, D, then I need to do again, leg squared plus leg squared is, oops, not A to D. A to B, Mrs. Batchelder. Don't be crazy. A is up here, B is down here. So leg squared plus leg squared is hype squared. AB is the hypotenuse, so that's going to be AB squared. And our two legs, here's our right angle, are going to be 5 and 10. So 5 squared plus 10 squared is AB squared. We're going to get 25 plus 100 is AB squared. 125 is AB squared. And we're going to take the square root of both sides. We're going to get AB. 125 square root is 11.18. We would have had a positive or a negative, but lengths can't be negative. So there's my units. Let's go ahead and do the green. What can I use for that? Let's change colors here again. Let's try this hot pink right here. So the hot pink color, hope that's not too close to red for some of you. That was BC. So we're going to do leg squared plus leg squared is height squared. And BC is our height. So BC squared is going to be the hypotenuse squared. And the two legs are 7 and 3. So 7 squared plus 3 squared is BC squared. 49 plus 9 is BC squared. 58 is BC squared. And then we'll take the square root of both. And I'm getting 7.62. Would have been plus or minus, but negative length doesn't make sense. And I just wrote a negative sign. Silly as bitch. So 7.62 units is BC. We had AD over here. The only one we have left to find, scroll up a little bit here, is C to D. So we've got to figure that one out. Let me see if I can change this color to, I don't know. Let's use this brown thing. So C to D is going to be this brown ugly color, unless you like brown, in which case it's this delightfully brown color. And we're going to do for C to D, leg squared plus leg squared is height squared. And our two legs are 2 squared and 8 squared. And our hypotenuse is CD squared. So 4 plus 64 is CD squared. Add those together, I get 68 is CD squared. Square root both sides. And the square root of 68 8.25 is CD. And we're going to add units on that because we're not going to be cheap. And then to get our perimeter of our entire quadrilateral, the perimeter of quadrilateral A, B, C, D, all we're going to do is add up the sides. So from A to B is 11.18. From B to C was 7.62. From C to D was 8.25. And from D back to A was 10.05. And we add those all up. 11.18 plus 7.62 plus 8.25 plus 10.05. And I'm getting 37.1 units. And remember, perimeter is plane units, area is square units. So our perimeter was 37.1 units, and our area up here was 83.5 square units. Okay, so now you guys are going to do this practice problem, find the area and the perimeter of ABCD. You're going to show quality work, and then go ahead and check your solution with the answer key that's going to be provided for you. Please reach out to your geometry teacher. We are looking to have you send us an email if you want some extra help. We would happily schedule a Google Meet. If you have questions, please do that. Okay? Take good care. Really wish we were doing this in real life, but we have to make the best of what we can. Hope you're doing well. Take care of yourselves. Bye-bye.